I've migrated a pretty complicated project that heavily relied on deep links to Navigation 3, and in this video I'll show you how you can handle deep links in Navigation 3, how you can do that when you have single backstack, how you can do that when you have nested backstacks, and some pitfalls on the way that you have to be aware of. The best thing about Navigation 3 is that we own the backstack and we can manipulate it the way we want, and on top of that we can also test this manipulation of the backstack. Before we get started, I have to mention that in order to handle any deep links on Android, we have to define an intent filter where we are going to specify the specific deep links that we are going to handle. As you can see here, this intent filter is defined inside my main activity, which means when there is an intent with specific deep link, it is going to fire up my main activity. Inside my main activity, I'm gonna get that deep link inside the intent data or data string if I want to get string type. Then I'm simply passing the data string inside my nav root, which is a composable where I have defined my backstack. I am having here the main nav display, which uses that backstack to add certain destinations. And I've defined three destinations or three entries here, which is the welcome, main, and some detail screen. So all we have to do here is create some matching for a specific deep link to figure out which destination we are going to open. As I mentioned, one of the best things about Navigation 3 is that we own the backstack, which is a simple list, and we can manipulate it the way we want. In that sense, I'd like to make sure I'm parsing the deep links properly and I'm opening the correct destination. So I'm gonna start off by writing a test for that. I'm gonna go ahead and create a package first, and inside I'm gonna create a new test class. Let's name it Deep Link Resolution Test. The first case I wanna cover is a fallback. So when my application can handle a specific deep link, but there is no specific destination to open, I'd like to open a default destination. So I'm gonna name this test returns default destination. As always, I'm gonna start from the assertion and I'm gonna assert that the result is equal to the default destination. Next, I'm gonna define what the default destination is, and I'm gonna create a local variable for that. In this case, I'm gonna use my main root destination. Next, I'm gonna define the result again as a local variable, and this result will come from a call to my deep link resolver. Finally, I have to define my deep link resolver as a local variable as well, and I'm gonna call a deep link resolver constructor of class that doesn't exist. And now, because I don't have any deep link resolver yet, I'm gonna create a class for it. Initially, I'm gonna keep the class inside my test. And now, in order to make it compile, I have to define a resolve function, which is going to be a member function inside the deep link resolver. I'll make the resolve function return nav key as a result. The nav key is a marker interface inside the Navigation 3 library that is basically used for marking specific destinations. And since all my destinations are already defined as nav keys, for example, main root is already a nav key, this is simply going to work. Ultimately, I'm going to return a destination from here. I am deliberately returning welcome destination to make the test fail. Now let's run it and see it failing. And indeed, the test failed because of a mismatch. And to make it work, instead of the welcome destination, I have to return my main root destination. And now, since the test is passing, I believe it's gonna be a better API if we allow the deep link resolver take in a fallback destination rather than hard coding it from here. To do so, I'm gonna extract the main root destination as a constructor parameter. I'm gonna run the test to make sure I didn't break anything. Then I'm gonna apply some formatting. I'm gonna change the type from main destination main root to nav key. And ultimately, I'm gonna make this property private. The test remains working, and ultimately inside my test I'm going to pass the default destination as a parameter to the deep link resolver constructor. So far so good. We can make a commit and proceed with another test. If you're an Android developer aiming to land roles that are exceeding 150k USD per year, but you are scared or insecure to go and crack such interviews, find a link below this video and let me scale your Android development game so that you can land such roles in the next 6 months to 1 year. In this test I want to make sure I can handle article details deep link, and because the entry that's gonna handle my article details is called home item details, I'm gonna name my test returns home item details destination. Next, I'm gonna assert that my result is the home item details destination, and the home item details takes in an item ID, and as an item ID in the home item details I'm gonna pass article ID. Now let's make this compile. First I'm gonna define an article ID, and then I'm gonna define the result. The result will once again come from the deep link resolver, and as an argument to the resolve function this time I'm gonna pass an article details deep link. Let's create a local variable for it, and then as an article ID I'm gonna pass my article ID variable that I've created before. Finally, let's create a deep link resolver instance, and now let's run the test and see it failing. Indeed, the test fails because we are expecting home item details with a specific item ID, but we are getting back the welcome destination. To make it work, I'm going to create a regex that would match the specific deep link. And then inside my resolve function, I'm going to check if my regex can match the deep link. And I'm going to assign this to a variable, and I'm going to call it article match. Next, I'm going to check if the article match is not null, and if that's the case, I'm going to parse out the article ID from it. I'll return my home item details destination. Now, to parse out the article details from a match, I'm going to use the group values. In order to get the article ID in the groups, I have to wrap this into brackets. Now, let's run the tests and see what happens. Alright, the test passes. Now that the test passes, let's think of some refactoring. If I want to support more deep links, I'll have to define more regex variables here and grow this resolve function, which is not very robust. It will make the code grow in size and complexity, and that's not the best thing we can do here. Instead, what we can do is we can extract some matchers, and then when we want to add support for new deep link, all we have to do is define a new matcher. Let's see how we can do that. First, I'm gonna create an object here, and I'm gonna call it article details matcher. I'm gonna copy my regex inside it, and then I'm gonna create a match function that will take in a deep link and return a nullable nav key. Then I'm gonna simply copy the logic that I have in the resolve function into the match function. Ultimately, I'm gonna leave the return in front of the let expression. What I ended up with now is a self-containing article details matcher that can take care of matching article detail deep links, and if I have to change something, I'll have to only change this particular object. Next, inside my resolve function, I'm gonna change the call to call my newly created object. And now if there is a match, the actual match is a nav key, so I will have to return the match itself. Now let's run the test to make sure everything still remains working. And ultimately, I'm gonna go ahead and remove the article details regex. Now I'm gonna extract the article details matcher object outside of the deep link resolver. And now if I want to add support for more matchers, first I have to create a more generic type or an interface. And the simplest way to do so was to extract an interface out of this object, but that support inside Android Studio stopped working. So if I try to refactor and say extract, there is no extract interface, unfortunately. Also, if I type interface, there is no interface extraction, so I have to do that manually. So let's create an interface, deep link matcher, and then I'm gonna take the signature of the match function and paste it inside. Ultimately, I'm gonna make my object extract from that interface, and I'll make the match function override from a parent. Everything should be still working. So far, so good. And now if I want to add support for another deep link, all I have to do is create a new object. Now let's go ahead and write a new test for matching a deep link for the user details destination. I'm gonna name this returns user details destination. As an assertion, I'm gonna assert that the result is equal to the user details destination. And as an ID, I'm gonna pass the an ID. Let's create local variable for an ID. Then I'm gonna create local variable for the result. The result will once again come from the deep link resolver resolve function call. And as an argument, I'm gonna pass the user details deep link. Let's define the user details deep link as local variable. And ultimately, let's create the deep link resolver. We have one test failing, and it fails because we're expecting user details with a certain user ID, but we got back the welcome destination. So next, let's create a new deep link matcher object, and I'm gonna name it user details matcher. I'll make it derived from the deep link matcher, and I'm gonna mostly duplicate the logic from the article details matcher. The difference this time is that the user details regex is having a different deep link, but again, I'm using a group to be able to group the user ID. And then inside the match function, if there is a match, we are returning user details. Now all we have to do is make sure that we are including the user details matcher in the deep link resolver. I'm gonna go ahead and make a call to the user details matcher here, and if the result is not null, I'm gonna return it. Now let's run the test and see if it works. And it does. Now that the tests are working, let's do a little refactoring here. The way this resolve function is growing is not nice. So what I'm gonna do is I'll create a list of the matchers that I know about, and then I'm gonna loop through them. While looping, I'm gonna call a match to each and every one, and if it happens to be a match, I'm gonna make an early return. Ultimately, I'm gonna go ahead and comment out the code that I had before and make sure I didn't break anything. Next, I'm gonna delete the commented out code, and I'm gonna extract the list of matchers as constructor parameter as well. Then I'm gonna make the matchers private, and I'll improve the formatting a little bit. And ultimately, I'm gonna remove the unnecessary value inside the resolve function. So All I have to do if I want to support another deep link is just create a new object, make sure it works by writing a test, and then add it here inside the list. What I'm gonna do next is extract all this code in the production packages, and we'll continue from there. If you're working with Compose, you know that oftentimes it happens that you know how to do something, but you don't remember exactly the syntax or exactly what was the construction to use. Because of that, I've paired up with Martin Moscala and we created comprehensive cheat sheets that are super helpful when using with Compose, so you can use them hand in hand with your Android Studio so that you can quickly find specific things that you need while working with Compose. Find a link below this video and go grab them quickly. Back to our Compose code, we've got our deep link, and all we have to do is use our deep link resolver to resolve it to specific destination. To do so, I'm gonna create a deep link resolver instance here, and as a start destination, I'm gonna pass my welcome destination. Next, I'm gonna use a launch defect where as a key, I'm going to pass my deep link. Passing the deep link as a key to the launch defect will make sure to re-execute the launch defect when the deep link value changes. Inside, I'm gonna simply check if the deep link is null, and if it's not, I'm gonna make a call to my deep link resolver to resolve it to a destination. Ultimately, I'm gonna add that destination on top of my backstack. Now you'll have to check what do you wanna do in your case. Maybe you'd like to clear the backstack before adding a destination, so that destination is gonna be the top one. Or in my case, because I have the backstack having as a default the welcome destination, it wouldn't make sense my deep link resolver to resolve to welcome destination again. So I'm gonna use my main route here instead. Now let's go ahead and run the application to see how does it behave. Inside my messages, I have added both deep links that we are about to handle. Here I have article with an ID and I have user with user underscore ID. So if I click on an article ID, it opens my welcome, and on top of that, it adds my home item details. So if I go back, it goes back to my welcome because the welcome destination was the default of my backstack. But then if I click on the user is a destination that happens to be inside my main screen as a sub nav graph. So inside my main screen, I have another nav display that has its own backstack. And inside this nav display, I have an entry that defines the user details. So if I go ahead and click my user ID deep link, it crashes the application. And if you take a look in the logcat, it would say I couldn't find such destination. It says unknown screen user details. And that's because in my nav route, once I parse out the deep link, I'm trying to add it to a backstack which is bound to a nav display that has no clue about that particular entry. And we are gonna see how to do that just in a moment. And that brings us to thinking about how do we resolve an entire stack. So here I have a backstack that has a default welcome destination, and then on top I'm adding a destination that I'm resolving. So what happens if I want to resolve an entire backstack? Well, one thing that comes to mind is to have our destinations have a parent, and then particular destination that we are going to resolve that would have a parent, and then we're going to have the ability to resolve to a list of destinations that we can simply add to the backstack. And that would work if you're having a single backstack. So if our backstack is one, we don't have nested backstacks like I have now in this case, it would work. Now, once again, depending on your situation, you can either resolve a single destination that you are going to add to your backstack, or you can change the resolving of the deep link into maybe a list of nav keys or destinations. And then you can add all of those destinations to your backstack. In that case, you may want to clear the backstack before and then add all of the destinations that you are going to resolve as a list. And because we can unit test all these decisions and all the resolution, it should be easy for you to create that list. All you have to do is pay attention to the order of the destinations that you are adding to the backstack so that the back navigation works properly. As we saw before, we have a slightly bigger problem when we are having a subgraph. For example, in this case, I have nav display that has a screen inside, which is this main screen, that internally has its own backstack and its own nav graph or nav display. And so in this case, if I want to resolve a destination that exists inside this nav display, I'll have to resolve a tree. And so next, let's see how we can do that. Back to my deep link resolver, I'm not going to change the resolve function because this is code that is publicly available, so you can see what makes sense for you best or what is your situation. I'm going to leave the resolve function as it is, and I'm going to add one more function here that I'm going to call it resolve tree. Once again, I'm going to take in the deep link and return a nav key. Return the default fallback destination when there is no match. But when there is a match, unfortunately, we couldn't generalize a solution like we did here with a for loop. Instead, for each and every match, we'll have to build the tree manually. So either we can integrate that inside the matchers, or we can do that here in a when statement or something similar, depending on what works for you best. And for the purpose of this demonstration, I'm going to do that here inside this resolve tree. First, I'm going to resolve the target destination, and I'm going to use the resolve function for that. Then I'm going to put the destination in a when statement. Then I'm going to check if the destination is home item details. I'm simply going to return it. Because when that's the case, I'm only going to add the destination on top of the backstack, which already knows for that destination. In the case of user details, if I open the emulator, the destination lives inside my main. I have to open a profile and then click go. So as we can see, that destination is inside the main stack. So the bottom navigation is still being visible. The profile tab is selected, and then I have that destination that goes further, even deeper inside the stack. To be able to resolve this, I have to open my main root, I have to make the profile tab selected, and I have to pass the user details as a child destination. Now my current destinations are not supporting this, so let's go ahead and alter them. The main root first has to become a data class. It has to take in the selected tab, which by default is going to be null. And additionally, I'm gonna add a child destination nav key that is also going to be null. Back to our deep link resolver, we can do some adjustments inside the resolve tree function. We can put the destination inside the when statement. I can add an else statement that will resolve to fallback destination. And then I can lift the return in front of the when statement. Now, if I go back to my nav root, I have to call the main root constructor because I turned it into a data class. And ultimately, when I'm calling my main screen, I have to pass there the arguments that are coming in the destination. So each entry here implicitly has an argument in the lambda, which is the destination. And from this destination, I can read the arguments. I can say selected tab is destination selected tab, and child destination is going to be the destination.child destination. Now let's go ahead inside the main screen and define those arguments. I'll mark them null by default. For selected item, we have to check if the selected tab is not null. And when that's the case, we have to find which tab matches so that we can have that as selected item. And because it's super easy to do and I want to make the video as short as possible, I'm gonna skip over that. It's gonna be a homework for you to do. And here, all we have to do is add the potential child destination, if it's not null, to the main backstack. As a last step in the nav root, instead of calling our resolve function, we have to call the resolve tree function. Now let's run the application and see what happens. I'm gonna go ahead and click the user details deep link. As we can see, it did open the correct screen and also it passed the argument. So we are getting the correct argument here inside the screen. If I navigate back, it opens our main root, but because I didn't make the change to make the proper tab selection, by default we get the home. And then navigating back opens our default nav backstack destination, which is the welcome. Now the last trick I want to show you is something that is very helpful if you're having some form of server-driven UI, and then the navigation is also driven by the server. So the server can give you some form of UI where click on particular item should resolve to a deep link to different screen. In that case, what you can do is your deep link resolver can extend from a URI handler. That's gonna force you to override the open URI function. And what you can do in this case is you can resolve the deep link by using one of your resolving functions, and you can expose a callback on the constructor side to do something with that deep link. In this case, I'm gonna define a lambda that I'll call on destination, and I'll default it to an empty lambda. And then inside the open URI function, I'll try to resolve the URI that comes in by calling the resolve function. And I'll pass this destination to the onDestination lambda. Then inside our compose code, we can wrap any composable into composition local provider. And then as a local URI handler, we are going to pass our own custom deep link resolver. Then we are gonna wrap our composable into the composition local provider. And as a deep link resolver, I'm gonna define a variable on top of the composable. As a fallback destination, I'm gonna put the default of the backstack, which in this case is the selected item destination. And then on destination, I'm simply going to add it into the backstack. Now let's see how this setup is helpful. For any composable that is inside this local composition provider, so for example, I can open my screen, then I can have, let's say, a button which on click does something. In this case, does on navigate. But imagine I'm having a server-driven UI, and this button comes as a definition in some form of UI that comes from the backend. And then on click, I have to handle a deep link that is coming inside that response from the backend. And so what I can do is I can take the local URI handler from the composition, which basically is our custom deep link resolver, because we set to that composition in the main screen that we are wrapping. The current local URI handler is going to be our deep link resolver. So essentially this thing here is something that we are gonna get here by calling local URI handler current. And then for the button click, I can just say URI handler open URI and then specific URI. This on destination is going to be called, and it will navigate there. So if you're having a server-driven UI, this sort of construction, this sort of setup is very useful, and obviously you can wrap this nav display into your own custom composable nav display that will wrap this local composition internally, and then you are also going to reduce the code duplication that way as well. Now this is something that I'm utilizing as a pattern for my project at work, where I have part of the navigation coming from the backend as a server-driven UI. Now that's it. I hope this video makes it easier for you to establish deep links working with navigation tree. As a recap, you have to remember that you can resolve to a single destination that you can add to the current backstack, or you can resolve to a list of destinations that you can add to the current backstack, and both of them work when you're having a single backstack. And ultimately you can resolve a tree of destinations, which is more helpful when you're having nested nav graphs. If you find this video useful, let me know in the comments below, and if you have a specific use case that wasn't covered in this video, also let me know so that I'm gonna make additional video for that. If you're an Android developer aiming to land roles that are exceeding 150k USD per year, but you are scared or insecure to go and crack such interviews, find a link below this video and let me scale your Android development game so that you can land such roles in the next 6 months to 1 year.